Hello and welcome to 7.2 Notes. So in 7.1 Notes, we went over the Pythagorean theorem, which basically states that if you start off with a right triangle, okay, you must have a right triangle. It only works with a right triangle. So given that you have a right triangle, the square of the length of the hypotenuse of a right triangle is equal to the sum of the squares of the lengths of the two legs. Again, that's true only in a right triangle. Basically, c squared equals a squared plus b squared, where c squared has to be the hypotenuse. Well, the converse of the Pythagorean theorem is also true, and we can use the converse of the Pythagorean theorem to verify that a triangle with given side lengths is in fact a right triangle. And that's the topic for today, the use of the converse of the Pythagorean theorem. And so the converse of the Pythagorean theorem states that if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle must be a right triangle. And they use the term here longest side because you don't really know if it's a right triangle or not, right? You're just trying to verify that. But once you do verify or have verified that it's a right triangle, then of course the longest side is the hypotenuse. Okay? So in other words, the Pythagorean theorem says, hey, with a right triangle, c squared equals a squared plus b squared. But the converse of the Pythagorean theorem is also true, and it says, hey, if c squared equals a squared plus b squared, then you must be talking about a right triangle. So that's how we can show or verify that a given triangle with these certain side lengths is in fact a right triangle or not, right? So moving right along, here's the picture for that to help you with the converse of the Pythagorean theorem. So it basically states that if c squared, and remember c has to be the longest side or the hypotenuse if it is in fact a right triangle. If c squared does in fact equal a squared plus b squared, then triangle ABC is a right triangle. Okay? Okay, let's see what kind of problems you'll be getting for tonight's homework assignment. Tell whether the given triangle is a right triangle. And here's my given triangle. And we want to find out if this triangle is a right triangle. So we use this equation, is 3 root 34 quantity squared equal to 9 squared plus 15 squared. Keeping in mind that this 3 root 34 must be considered the c. It has to be the one out here all by itself because 3 root 34 is the longest side. And so if this was a right triangle, then this would be our hypotenuse. So it has to be 3 root 34 quantity squared is equal to, and then you can just have the 9 squared plus the 15 squared on the other side. Okay? And also I want to mention sometimes you're going to get problems like this, but you're not going to have the picture. You're just going to have 3 lengths listed like that. And so what you might have to do in that case, or even in this case, if you don't know that 3 root 34 is the longest value, is you might have to whip out your calculators and take the square root of 34 and then multiply that value by 3 and get a decimal value. Okay, and then compare that decimal value with 15 and compare it with 9 and find out that yes, 3 root 34 is the longest side, and if this was a right triangle, that it would be the hypotenuse. So that's where we get this equation from, right? Is 3 root 34 quantity squared equal to 9 squared plus 15 squared? Is that true? We don't know. Okay, so the next step is I'm going to take 3 root 34 quantity squared, which is equal to 3 squared times root 34 squared. And again, does that equal 9 squared plus 15 squared? Okay, and then 3 squared is 9, and root 34 squared is just 34. So we get 9 times 34. And does that equal 81, which is 9 squared, plus 225, which is 15 squared? And then we find out that 9 times 34 is equal to 306, and 81 plus 225 is equal to 306. So obviously 306 equals 306. So then 3 root 34 quantity squared equals 9 squared plus 15 squared. That can only happen if this is a right triangle, people. So the triangle is a right triangle. See how that works? So we've seen how the converse of the Pythagorean theorem is used to verify that a given triangle is a right triangle. But we also have theorems that we can use to verify that a given triangle is either acute or obtuse. Okay, so let's investigate that a little bit. So here's one for an acute triangle, and it says if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is an acute triangle. So if we have this relationship here, if c squared is less than a squared plus b squared, then the triangle is acute. So you take this longest side of a triangle and square it, and then compare it to this squared plus this squared. And again, if c squared is less than a squared plus b squared, then the triangle is acute. Similarly, if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is an obtuse triangle. So if it's greater, it's obtuse, and if it's less, it's acute. Okay? So again, I just rewrote this. You don't have to write it again. And it shows that if c squared, or the longest length squared, is greater than a squared plus b squared, then it's obtuse. Okay? So we have these theorems, these three theorems that we've just gone over from this lesson, from lesson 7.2. These three theorems are going to be used, or can be used, to classify a triangle as either acute or right or obtuse based on its side lengths, right? So if c squared equals a squared plus b squared, then it's a right triangle. Okay, Pythagorean theorem. But if c squared is less than a squared plus b squared, it's acute. Try to associate the less than symbol with acute, right? Smaller or less than 90 degrees. And then if conversely the c squared is greater, okay, then think of greater than 90 degrees. Think of obtuse. So you can associate the greater with the word obtuse. Okay? So you will be responsible for these three theorems, for knowing them and knowing how to use them. They're also in your textbook under concept summary for your notebook. And how will these theorems be used? What kind of problems are you going to get? Good question. Well, here's a question. Show that segments with lengths 3, 4, and 6 can form a triangle, and, so there's two things we need to do, and classify the triangle as acute, right, or obtuse. So it's not really a question, folks. It's a problem, mathematical problem that we have to solve. Keep in mind this word and, though. We have to do, two things to it. So there's two parts to this problem. So first we'll try to find out if we can even form a triangle, if these three lengths can even make a triangle. Okay? And we do that, remember we covered that in a previous chapter. We have to show that the two sides are greater than the third side, and the other two sides are greater than that third side, and the other two sides are greater than that third side. All three of those inequalities must be true in order for you to be able to make a triangle. If any one of them is not true, then you can't make a triangle. Okay? So, let's see. Moving on here. Yes, so 3 plus 4 is 7. 7 is in fact greater than 6. And 9 is greater than 4. And 10 is greater than 3. So they can form a triangle. And 6 must be the hypotenuse, right? Because 6 is my greatest value. So 6 has to be my value for C. Okay? 6 has to be my value for C. That's why I put the 6 out here and square it. It's the one that's all by itself. It's the one that if it does equal a squared plus b squared, then it's a right triangle. And if it's less than, it's acute. If it's greater than, it's obtuse. But it has to be here, again, because it's the greatest value. Okay, and then moving right along, we have 36, and how does that relate to 9 plus 16? And then we have 36, and oh, how does that relate to 25? Well, clearly you know that 36 is greater than 25, so that must mean it's obtuse. Okay? So that's the end of the lecture. If you have any questions or concerns, as usual, please feel free to contact me at your convenience, and it would be my pleasure to help you. Okay? Bye-bye.